Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing very good. So students, in this video we are going to solve the question from the chapter Electrostatics asked in the JEE 2025 exam. Is it? And in this question you will see that when the dielectric is inserted between the capacitor plate, in which situation we can tell battery is disconnected and in which situation we can tell battery remains connected. Okay, so first let's go through the question. The question is, kindly see here, a parallel plate capacitor of capacitance 40 microfarad is connected to a 100-volt power supply. Now the intermediate space between the plates is filled with a dielectric material of dielectric constant K equal to 2. Due to the introduction of dielectric material, the extra charge and the change in electrostatic energy in the capacitor respectively is how much here. So in the question they are asking what is the change in charge and what is the change in electrostatic energy. So here you remember that one thing, when the battery, what I am telling, when the dielectric is inserted and the battery is disconnected, then charge will be same. That means change in charge will be 0. But here you can see no other options are there in which change in charge is 0. That means this is the case of second one. That means after insertion of dielectric, what is there? The battery remains connected. In that situation, what will happen? Potential will be same and change in potential will be 0. Is it? So all these things may be little bit looking confusing, but now we will see that here. Okay, I will just tell you, then we will solve this question, not a problem. So see here, remember that here I have taken here the battery disconnected after dielectric insertion. So here you can see very well, one capacitance is there, C0, and let's take the battery is V0. Now what we are doing here, in this situation, we are disconnecting the battery. Okay, so what is happening that here, see, in this situation, we have put here one dielectric, no? This is a dielectric is there, I have put here, and capacitance has become C, okay. And anyhow, if in case here charge is Q0 and here charge is Q0, then here let's take charge is Q and here charge is Q minus Q, no? Because plates are having opposite charges. And let's take here the new potential difference is V. Okay. So already I have made the video on the electrostatics, you can see that, but directly I will write here. So what I am telling you, remember that here, first thing, here the charge will remain same, the most important. What will happen? The charge will remain same when the battery is disconnected after inserting the dielectric. Okay. Second thing, what is happening that here, capacitance C will be equal to Kc0. Okay. And the third one, if I talk about the potential will be V equal to V0 by K. If I talk about the electric field between the plates, it will be E0 by K. And last one, if I talk about here the energy, so energy will be U0 by K. Is it? So these 5 things are there. After that, if I talk about the second one, the battery remains connected after dielectric insertion. So here let's take here capacitance C0, battery is V0, and what we have done here, see here, this is the situation, no? So let's take here potential is V and charge, let's take here charge is Q0, here minus Q0, here charge is Q, here charge is minus Q. Okay. And what is happening that here we are inserting one dielectric, and in that situation let's take capacitance is becoming C. So here you can say C0, Q0, V0, here C, Q, V. So here you have to remember that here in this situation the potential will be same. This V will be equal to V0, the battery remains connected. Next one, what will be there? Remember that here if I talk about the capacitance will be as it is, C equal to Kc0. Third one, remember that the charge, the new charge will be Q equal to KQ0. Okay. And if I talk about here the electric field will be same, equal to E0 because potential is same. And last one, if I talk about the energy will be K into U0. Is it? So this thing you have to remember that. Now you can see very well our question belongs to the, which one, first one or second one? Our question belongs to the second one here. Is it? Second one. So again we'll go to the question and we can note down the data here. Initial capacitance is given here 40 microfarad here. Okay, so we can write here, no, initial capacitance C0 is given here how much here? 40 microfarad, that means 40 into 10 power minus 6 farad. After that the supply voltage, that means V0 is given here. How much is given here? Kindly see here 100 volt here. Okay. And we are keeping one dielectric constant. How much is given here? Dielectric constant is given here 2. Okay. And they are asking the change in charge and change in energy. Na? All this data is given here. Na? Kindly see here. So now students, let's see here. They are asking the change in charge. You can see here the new charge is this one here, na? Q equal to KQ0, and energy is this one here, is it? So we'll go to the, see here. So as I have told you very well, the capacitance is given here how much here? 40 microfarad, 40 into 10 power minus 6 farad, okay. And after that, if I talk about here the potential is given here the 100 volt, na? So 10 to the power 2 volt, and the dielectric constant K is given here 2. This is the situation, okay. So what we know that here in this question, the battery remains connected. That means this is a part of the second one here. So if I calculate the change in charge, so change in charge how much here? Q minus Q naught, na? Battery remains connected, so this Q will become here KQ naught, as I have told you, and minus Q naught. So what this will come here? It will become here K minus 1 into Q naught, na? So we can write here K minus 1, Q naught means here C naught into V naught here, is it? Remember that here. Now kindly see here, K value how much here? 2, so we can write here 2 minus 1 into capacitance how much here? You can see here 4 into 10 to the power minus 5, and here how much here? You can see here 10 to the power 2. Is it, students? So you can see very well. Here it will become here 2 minus 1, 1 into 4, 4 into 10 to the power minus 5 plus 2 means minus 3 coulomb. So we can tell here it is coming here 4 millicoulomb. That means change in charge when the battery remains connected is a 4 millicoulomb. After that, second one if I talk about here, what is the second one? Change in energy, delta U. So here also we can write here U minus U naught. So what is U? U will become here, as I told you, KU naught minus U naught, is it? So I can write here K minus 1 U naught, is it? So here you can see the students, K minus 1, and this U naught value how much here? Remember that here in case of capacitors, half C naught V naught square here, is it? See, we have got the formula. So what will become here? K minus 1, K means 2, so we can write here, see, 2 minus 1 into half, is it? And what is the value of the C naught? You know very well, 4 into 10 to the power minus 5, and they are telling here V naught square. V naught square is how much here? 10 to the power 4, is it? 10 to the power 4. So you can see very well here, this will become 2 to the 4, 2 to the 4, this is 1 only. So this will come here 2 into 10 to the power here minus 5, and here 4, see, these are minus 5 here. So it will become here minus 1. So it will come here how much here? 0.2 joule. Can you see very well? So change in charge is 4 millicoulomb, and the change in energy how much here? 0.2 joule, is it? So now we'll go to that. Which option is correct here? 4 millicoulomb and 0.2 joule. The correct option is here option C. Is it? So students, I hope so. This question of dielectric insertion is very, very clear to you. Keep studying, keep growing.